All right, we are starting right away.
Okay.
All right, so
But we can't see the screen.
yeah, I'm about sharing the screen now. So can you see the screen now? Can we all see the screen?
No, please.
Okay.
No, it's the
We,
same as
we can't,
yesterday. The cup.
we can
Okay.
only see the cup.
All right.
There is clear
Yes,
now.
yes. Okay now.
All right.
We can see it.
We can see it now.
All right.
Yes.
So today we want to talk about we want to start what we plan doing proper. So now we want to start simulating Arduino. But before we do that, I would want us to understand what we mean by Arduino and microcontroller. So, as I was saying before, now Arduino is a development board, just like other development boards that we have. Just that Arduino is kind of popular. We have different types of development board. We have STM32. I think that's the reigning one currently. We have Raspberry Pi. We have a lot of them, but Arduino is like the most popular one in the market because of the community, the large community. Now, Arduino is not a microcontroller. I want you to get it clear. Arduino is not a microcontroller. Arduino is a development board that uses Atmega 328P microcontroller from AVR to build their board. So Atmega 328P is actually for Arduino Uno. So we have other Arduino boards, Arduino Mega, Arduino Nano, and a lot of them. But they use the Arduino platform uses AVR microcontroller to build their development board. But Arduino is not a development board. I don't know if we got that clear. Are we following?
Yes.
All right. So
Yes.
having said that, now if you want to build a project, and you decide to use Arduino, it means that you have minimum configuration already done for you. So what you have to do is just to write your code and run your code, connect your sensors, and everything will start working. But if you plan using a single chip, a bare metal microcontroller, you have to write your code from scratch. You have to build your circuit from scratch. So I want to show you guys something. Let me try and on my video on my camera. So I want to stop sharing so that I can show you guys. Okay, so this is Arduino board. Hope you can see it.
We are not hearing you.
Okay, this is Arduino board. Hope we can see it. Can we see the board?
Yes. Yes.
All right, so this is Arduino
Yes.
board.
Yes. Of course.
This is the complete Arduino board, and this is a controller. This is a microcontroller. And this is a microcontroller. This is a single microcontroller. So this is inside Arduino board. It's inside Arduino board. So if you want to build your project, you don't want to use this complete Arduino board because this is a little bit costly, and you don't want to use this. You can get this. You can get this and build your own board and customize your own board like this. So what I'm having here, I'm trying to build a project that monitors the air quality. So I decided to build the board from scratch. So instead of using Arduino board, I decided to build my own board. So that's what you are having here. This is the microcontroller. So having said that, let's go straight to the simulation. I want to show you the step that you need to take when you plan simulating Arduino using Proteus. So can we see the screen now?
Yes, yes.
All right. So the first step is you open your Proteus simulation software. Then you create new project. Then you type the name. Let me call it simulate Arduino.
Yes. Excuse me, sir.
Yeah, I can hear you.
What's the topic again, please?
Yeah, we want to
The topic
we said okay, we want to start simulating the Arduino
simulation.
inside our Proteus simulation software. That's what we want to do now.
Good.
So
Okay. Thank
the
you. Go
first
ahead.
thing is to create the project. Then you write the name of your project. Then we next till you finish. So once you see this environment, you click on this second component in the component mode. So you click on component mode, then you click P, then write what you want. So we want to bring out Arduino. We want to use Uno. So we want to use Arduino Uno. This is Arduino Uno. You double click. Then we need LED. Let's take red. Then resistor. Please, can we mute our mics, please? Then we select resistor. Okay. Then we want to draw the circuit diagram. Because I told you guys, before you can do anything at all, before you can build any project at all, the first step is to draw your circuit diagram. So now we bring our Arduino on the working environment. So we have a lot of digital pins. Arduino has a lot of digital pins. Digital pin 0 to 13. So now what we want to do, we want to blink LED. If you want to blink LED, turn LED on and off. You are sending signal. You are sending digital signal. So you are sending high, low. We are sending 0, 1, 0, 1, or high and low. So for you to be able to do that, you need to utilize the digital pins of the microcontroller. Because here we have digital pins and we have analog pins. Where these analog pins comes in handy is when you want to read sensor value. Like the circuit I showed you guys, I want to build a device that monitors the air quality. Now I need to monitor this. I need to monitor some components inside the air. Example, CO, carbon monoxide, sorry. Now if you want to monitor carbon monoxide, this is physical quantity. And the Arduino or the microcontroller cannot understand physical quantity. So you need to convert it to digital form. So for you to be able to do that, you need to utilize this analog pin, because what you are sending in is analog signal. Are we following? Hope you are following.
Yes.
All right. So now let's go back to the Proteus. Now, but what we want to do now, we want to send signal out, and this is digital signal. So we are using the digital pins from 0. You can make use of from 2 to 13, but we want to make use of 9, pin 9. So now we connect our LED to pin 9. But before then, we don't want to connect it direct. We want to connect a limiting resistor. So you connect a limiting resistor here. I don't want to use 10K. 10K is too much. I want to use 330 ohms. You say okay. Then you connect your ground. So we are done with the circuit. So this is the basic circuit for blinking LED. So the next thing to do now is to write the code. So we go to our sketch. So if you don't have this, you can easily download it. It's online. You don't have to worry about that. So we go to sketch. If you have any question, you can call my attention. Then you go to sketch. Then we create a new. Okay, let's go to example because we have that already inside the Arduino IDE. So you go to example, you go to basics, and you go to blink.
Please come again. You said you go to sketch.
Yeah, sketch is like IDE. We call it IDE.
Okay, from sketches then.
Yeah, you use this sketch to write. Now you want to write your code and send the code to Arduino board. So you need a tool to write this. You need a development environment to write this code. So the name of the IDE for Arduino is Sketch. So you can just write Arduino IDE on Google. You just give the option, you download. So once you download, you open it. Then once you open it, you go to example. Sorry, you go to file. Then you go to example.
File.
Yeah, file. You go to file. Then you go to example. Under file, you see example. Then to basics. Then blink.
To basic, then
yeah,
blink.
Then you go to blink, yes. So you click blink.
Okay.
Sorry, I had to do that again. I don't know why it's not responding. Okay. I think it's taking time to respond. Example, basics, blink. Hope you can see the screen.
Yes.
All right. So once you open your sketch, the first thing you do, you make sure that the name of the board you are working with is the same thing with the name that is up here. Or you can go to tools, board, and you select your board. So you make sure that the name of the name of the board here is what you are working with. We are working with Arduino Uno. You can decide to work with Arduino Nano, but if you are working with Arduino Nano, make sure that you select Arduino Nano here. But now we are working with Arduino Uno, so we leave it like that. Now this is an example code. This is an example code for blinking LED, but this default code works with pin 13. If you hover around it, you see pin 13, LED building 13, but we don't want to use 13. Remember, we connected our LED to pin 9, so we change this to 9. We change this to 9, and we change this to 9. Then I want to explain the code. So what you see here now is the first thing is the setup. In programming, we have what we call method. So this is a method. Inside this setup, you do all your setup, all your pin setup. Say you want to blink LED. So you want to blink LED. That pin that is connected to the LED is output pin because you are sending signal out on the LED, off the LED, on LED, off LED. So you are sending signal out. You should be output. But if you are reading something from a sensor and taking it into the microcontroller, it will be input. So you will change here to input. But since we are blinking, we are sending signal out to the pin of the controller. So we call this guy, we make it to be output pin. So the pin 9, here you put the number, the pin that you want to configure. Then at this particular point, you put whether you want it to be output or whether you want it to be input. But in this case, we want it to be output. So that's why we are having output here. Now the second one, loop. Once this code can only run once. The setup, any code that is inside the setup can only run once. So once you are done with the initialization, it will never run again till you off the system and turn it on again. But inside the loop, as the name sounds, this code will continually, it will keep running. After this first one, the second one will run, the third one will run, the fourth one will run, and it will start again. So now what we want to do, we want to turn on the LED. That's why we are saying high. High is like on. Then we wait for 1 second. We make it low, we off it, and we wait for another 1 second. Then we go back again. Are we together? Are we together?
You have to go over it too.
All right.
Yes.
All right. Okay. Let me go over it once more. Now, what we want to do, we want to blink LED, and now we want to blink LED that is connected to pin 9. Let me go back to the Proteus. So this LED is connected to pin 9, as you can see here. Pin 9 of Arduino Uno. Now, if you are writing your code, you should also make sure that the signal you are sending to the board, that the pin declaration is also pin 9. So initially it was LED building, but we don't want to use the default. We want to work with our own. That's why we Okay, I can hear you.
Sorry.
I can hear you.
Hello?
Yeah, I can hear you. I can hear you.
Is it pin 9 on the microcontroller?
Yes.
Okay. Yeah.
So now, after the setup, this setup can only run once. So once you set up your pins, you go into the loop. So now the work of this loop, any code that is inside this loop will execute every time continually. It will not stop. It will only stop when you turn off the system. But once the system is on, it will keep executing. So what we want to do, we want to on the pin, we want to turn it on, then wait for 1 second, then we turn it off. We wait for another 1 second, we turn it on again. If you've used any 555, like 55 timer, if you configure 55 timer in a stable mode, it will be blinking off, on, off, on, off, on. So that's the exact thing we want to do, but now we want to use Arduino, we want to write a little code to perform that action instead of using the 555. So that's exactly what we want to do. So after doing this, the next thing to do, you go to this bar, you click verify. So let me click verify. So once you click verify, it will start compiling. So we need to wait for some seconds for the compilation to finish. So it's compiling. So it's done now. So once we are done, now naturally, if you are using a physical Arduino, you just click this particular one, upload, and you upload your code to the board. But now you want to take the code to Proteus. So what you have to do is to copy this link. From here, you have C, user, HP, app data, blah, blah, blah. So you just copy from here, from C. You copy from C to this point. Then let me copy it. You copy. Then you open your file explorer here. You paste the link. So let me paste the link here. Now, for some IDE, you will not have this double slash, but some you have the double slash. So if you have the double slash, kindly remove the double slash. So you just remove the double slash. Just remove the double so that we will be left with just one. Remove and remove. So you click enter. So now look at what we have inside the link. We have a lot of files, but basically what we need is just this blink.hex, because what we are loading into the microcontroller is a hex file. So we need just the hex file. So we copy the link back. So go back to this thing and copy the link. So copy. Then we go back to our Proteus simulation software. So once you get to Proteus, what you do is that you double click on this Arduino. So you double click. So once you double click, you have where hope we can see the program file, the option that says program file. Can we see it? Can you all hear
Program
me?
file.
Can you all hear me?
Yes.
Hope we can see the screen, right?
Yes, please.
All right. So you paste the link here.
I want you to turn like this. How can I do it?
So you paste the link here. Then you click on this folder icon. So once you click on the folder icon, please can we mute our mic? So once you click on the folder icon, you open that link.
See one from here. Which one?
I think I'll have to
Okay.
mute. Can you hear me now? Can you hear me now?
Yes, please. We can hear you.
All right. Sorry for that. The stop got disconnected.
Yeah, the interface froze, so please if you can go over again.
Okay, but you can see the screen, right?
Yes, please. You can see the screen
Okay, now
and then the LED is also blinking.
All right. So let me go over it again. So once you copy your link,
Okay.
that part is clear, right? Once you copy your link, you double click on.
Yes.
Yeah, you double click on the Arduino, then you paste the link here.
To the program file.
Yeah. So you paste the link. Then you click on the folder icon. Then you click open. Now we have three files here, three hex files or .ino files. What we want is the .ino.hex file. So you select this. So once you select this, you open and you click OK. So once you must have done that, you start the simulation. So as you can see, it's taking a bit time because this is a simulation software. That's why it's taking a bit time to turn on and turn off. So if you want to increase the speed, we can go back to the IDE. So let me go back to the IDE. Then I will change this to, instead of 1000.
1 second.
Yeah.
Oh,
instead of
okay.
1 second, let me say 200, which is 0.2 seconds, so that it will be faster.
Okay.
So once you do that, you verify again. So it's verifying. So once you are done with the verification, you don't have to do like go over the whole process again. It's already there. So we stop the simulation and we play it again. As you can see, it's kind of moving faster than before. Are we okay?
Yes, please.
All right. So that's the steps that you need to take when you want to simulate Arduino inside your Proteus. Now, I don't know if we have questions before we go forward. Do we have questions? Do we have any question?
No.
No.
Okay. Since we don't have question, let's move forward. All right. So now, having done that, the next thing we want to do is that we want to connect LCD liquid crystal display to this microcontroller. Then after that, we connect a sensor, temperature sensor, DHT111. DHT11, that's the name of the temperature sensor we are going to be using. So I will stop the simulation. Then I'll go back to the component mode. I'll bring out LCD. 16:2 LCD. So you go down, this is 16:2 LCD. So you double click. We need temperature sensor DHT11. That's the temperature sensor. Then we say OK. So now I want to connect the LCD to the Arduino Nano. So I will do the connection. Because of time, I will do the connection very fast. Or maybe I will, let me go back. Let me just open another file that I've already drawn the circuit diagram because of time. Alright, so this is the circuit that we want to work with now. So now we have our LCD. This is the liquid crystal display. What we want to do is that we want to read the temperature using, like we want to read the temperature using this sensor. The name of the sensor is DHT1111 rather. So we want to read the temperature and display it on the LCD. That's what we want to do now. Read the temperature, display on the LCD. So now go back to our sketch. So I'm waiting for the IDE to load. It's taking a bit time. Okay. So now I've written the code. I'll just explain the code. Then we'll now export it to Proteus. Now, the first thing to do is you add header files. This is what we call header files. If you are writing your code in C or C++, you first of all add your header files. Now these header files contains the library you want to use, because naturally, I told you guys that Arduino is a development board. It's not a raw controller. Now if you are using your controller by yourself, you don't want to use Arduino, you don't want to use Arduino platform, you are going to be writing a lot of codes. But now some places have already written code for displaying whatever you want to display on LCD. So what you have to do is just for you to download their library and you start using it. So now this is the library for the header file that contains the library for the sensor, and this one contains the library for the LCD. So you don't have to start writing everything from scratch. So what you have to do is just for you to include the library and you start using them. Now let me go back to the Proteus. Now if you observe very well, our LCD, we connected our LCD from pin 8 to pin 3. That's the pin of the Arduino that we connected the LCD. Now if you go to your code, you observe that we have pin 3 to pin 8 too here. So you add those pins here. So the first one is the reset, the second one is the enable, then this one is D4 to D7. So if I go back to the Proteus now, this is D7, which is 8, D6 7, D5 6, Then if I go to my pin 3 now, pin 3 is RS, and pin 4 is E, which is enable. So this RW, you connect it to ground. So now we want to connect our sensor to pin 9. This is the sensor. So you connect it to pin 9. Now if you go to the code, let's go back to the code. This is pin 9. So that's the sensor. That's the sensor pin, DHT pin. So that's what these two lines of code are doing. Now here, can you all hear me? Hope you are following. Hope you are following.
Yes, please.
All right. All right. I wanted to be sure that you guys are still with me.
Yes.
All right. So now, let me go back to the sketch. So we have different types of this sensor. We have a lot of models of DHT sensors. We have DHT 11, we have 22. So we have a lot of them. So here you need to specify the type of DHT sensor you are using. So here we are using DHT 11. So that's why we are writing 11 here. If you are using 122, we just have to clean this and write 22 here. But we are using 11. Now here, you call this, you instantiate this method, and you pass in these two arguments, the pin number and the type of the sensor you are using. So that is what this line is doing. So now here, you start the sensor. So I told you that some places have already written the code. You don't have to write the code manually. Like you don't have to write your own code for starting the sensor. So here you just begin the sensor by calling dht.begin. So having done that, you also begin your LCD. All these things are initialization method that you need to call. You need to begin, you need to clear the LCD before you start. Now you need to set the cursor, blah blah blah. So this part is just initialization. Now inside the loop, I told you that here you do this just once. Anything that is inside this setup will run just once. After the initialization, then we are done. But the code, all the codes inside this loop, we keep on executing till you turn off the device. So the first thing to do is to read out your temperature. Initially, we declared two variables, these two. So any temperature you get, you save it inside here. The humidity, you save it inside here. I forgot to tell you guys that this sensor can measure both temperature and humidity. So we have two variables for doing that. This one for temperature, this one for humidity. Then you read your temperature. So this line of code is used to read the temperature, then save it inside this temp variable. You do that here, you do this here to read the humidity, save it inside the home variable. Then once you must have done that, now you display the temperature. So you use lcd.print, you put the value of the temperature, so you display the temperature. So this line of code now is used to write degrees, symbol of degrees. That's what this line of code is doing. So degree Celsius, C is for Celsius. The same thing goes with this guy. You jump to the second line. This is X and this is Y. So initially we are in X0, Y0, but now we need to jump to the second line of the LCD to display the humidity. So we use this line of code to jump to the second line. Set your cursor to Y1, sorry, so that you jump to the next line. Now you display your humidity and you add percentage. That's the unit. So having done that, you also verify the code. So I will click verify. So I will click verify. Then I will also copy the link. So I will copy this. Sorry. right, so I copy. Then I paste it here. Remember, some persons you will see this double slash. If you have this double slash, just change it to 1. We just need 1. But if you can't see the double, fine, you just move forward. So this, you remove the double slash. So 5 is here. You now copy this. So once you copy this, you go back to your simulation software and you double click process. Double click. Then you paste it here. You paste here. Then you go in. You click open. And you select the hex file, the second one. Arduino, like whatever you're going to see, you're going to be seeing the name of your project. Initially, the first one we did was the Blink. That's why we saw Blink then. But now we are doing Arduino _DHT11. That's why we are having files with that same name. So you double click and you click OK. So you click OK, then you start the simulation. So as we can see, it's actually displaying what we have inside the Arduino sketch. So here you have 19 degrees, 86% humidity. That's exactly what is showing on the sensor here, if you can see. Hope you can see the sensor. Can we see the sensor?
Yes.
All right, so I want to change the value
Yes,
now.
please.
I want to change the value. Then I will come down. You can use this thing to go either up or down. So I will come to temperature. Now I will increment. So let me increment it to 30. I will increase it to 30. So I have 30 here. My LCD should be showing me 30 now. So I have 30 here also. So if I reduce, let me go down to 25. So I have 25 here. Then let me change the humidity to maybe 75. So I have humidity 75, temperature 25. So that's exactly what is showing on the LCD. So do we have any question at this point? Any question at this point?
No, sir.
All right. So since we don't have question, I think we'll call it a day. From tomorrow, we are going to be using this particular setup too to design an automatic heater. We are going to be utilizing this setup and the code that we wrote. We are going to be tweaking the code a bit so that we'll simulate an automatic heater. So since we don't have any question, I will end the meeting right away.
Excuse me, sir. Hello, the question I have.
Okay.
Excuse me, sir.
Yeah,
Hello, sir.
I can hear you.
Hello?
I can hear you.
Hello?
I can hear you loud and clear.
Yeah. The only question okay, it's okay. The only question I have now is the installation of this. I'm almost at the same edge of the installation.
Okay.
So maybe tomorrow I will continue.
All right. Maybe after the call, you can send me.
Then also,
all right.
you want to practicalize this.
I can hear you.
Okay. I will do that. Okay.
All right.
Thank you.
All right. So.
Okay. What I'm saying is that hello. What I'm saying is that. Can you hear me?
Yeah, I can hear you. Please. I can hear you.
What I mean is that if you want to practicalize this what you have just taught us. This is a project.
Yes.
I think we have to plug this Arduino board to the system,
Yeah,
the laptop.
either you plug it to laptop or you
Is
power
that
it
not?
with external 12-volt adapter. You
Oh,
can plug it to your laptop.
okay.
It has two.
Okay.
ports. Let me show you.
Okay. But power it with like 5 volts.
Yeah, I think I will have to show you.
Oh,
Let me
okay.
stop the sharing and show you something.
Yes.
Okay, I can't find the Arduino board now. Okay, maybe I will send you that on. Okay, I've seen the Arduino board. So let me stop presenting so that I can show you something. So now,
It's okay.
can you see this board?
It's okay.
Can you see this board? Can you see the board?
Yes.
You have two ports. The first one,
I can.
yeah,
Yes, I can
the
see.
first one is the one you USB for your laptop,
Yes.
while the second one is normal adapter. So you can power it using either of these two.
Okay.
Yeah.
Okay.
All right. So let's have a lovely night rest.
It's all right.
All right.
Hello.
I can hear you.
Okay. It's all right. Tomorrow.
All right.
No, what I want to say is that I think to transfer the all these code into the controller,
Yes.
it is through the connection with the laptop.
Yes. Exactly. Yes.